A persistent check engine light that stays on after clearing diagnostic codes indicates an unresolved underlying issue in your vehicle's systems. This is different from a light that turns off after clearing codes, which suggests a temporary problem. Modern vehicles from 2024 and 2025 feature advanced onboard diagnostic systems, known as OBD2, that detect and report errors with much greater precision than older systems. These systems continuously monitor your engine's performance. The check engine light system has three primary functions. First, it monitors emissions control systems like catalytic converters and oxygen sensors. Second, it tracks engine performance, including fuel injection and ignition timing. Third, it verifies communication between various engine control modules. Based on 2024 industry data, there are 5 main causes of persistent check engine lights. Faulty oxygen sensors account for 28% of cases, followed by catalytic converter issues at 22%, mass airflow sensor problems at 18%, ignition system malfunctions at 15%, and EVAP system leaks at 12%. Ignoring a persistent check engine light can have serious consequences. Your vehicle's fuel economy can decrease by 10 to 40%, costing you significantly more at the gas pump. Additionally, continued driving with unresolved issues can cause long-term damage to expensive engine components, leading to much costlier repairs down the road. The first phase of troubleshooting begins with a comprehensive initial assessment using professional diagnostic tools. Use a professional-grade OBD2 scanner to retrieve all stored diagnostic trouble codes and document freeze-frame data for context. Check for technical service bulletins related to your specific diagnostic codes, as manufacturers often provide known solutions for common issues. Next, we move to the physical inspection phase, where we examine the actual components and connections. Phase 2 involves a thorough physical inspection of all related components, connections, and systems. Inspect vacuum lines, electrical connections, and sensors for any visible damage, corrosion, or loose connections that could cause the check engine light. After physical inspection, we proceed to component testing using specialized diagnostic equipment. Phase 3 focuses on testing suspected components using appropriate diagnostic equipment and manufacturer procedures. Test each suspected component using manufacturer-specified procedures, oscilloscope readings for electrical issues, and real-time data monitoring during drive cycles. Finally, we reach the repair and verification phase, where we fix the identified issues and confirm the repair. The final phase involves repairing identified components and thoroughly verifying that the fix resolves the check engine light issue. Replace or repair the faulty components, clear diagnostic codes using proper procedures, then perform a complete drive cycle to reset readiness monitors. Important note: in approximately 28% of cases, software updates are required in addition to hardware repairs to fully resolve the check engine light.